Good morning, Brunei friends. It's my great pleasure to have an opportunity to introduce our recent research trial to reduce the food loss. I'm sure you will enjoy today's my talk. Thank you very much.
I am Eiichiro Fukusaki of Osaka University. By the support of the Japanese government, we have launched a research center hub to solve the problem of food loss reduction through technological innovation by a combination of the latest technologies from fiscal year 2021. According to the FAO report, about one-third of the world's food production, or enough food for 2 billion people, is wasted, resulting in an annual economic loss of 80 trillion Japanese yen. On the other hand, the annual carbon dioxide emission from food loss is 3.6 billion tons, which is 80% of the world's total. Considering that China, the world's largest emitter of carbon dioxide, emits 9.6 billion tons per year. The United States, the second largest, emits 4.9 billion tons, and India, the third largest, emits 2.3 billion tons. We can see how important an environmental problem food loss is. Among the food losses, production loss, storage loss, processing loss, and distribution loss can be reduced by advanced technology. Furthermore, in order to reduce consumption loss, which are common in developed countries, it is necessary to change the mindset of consumer. With the vision of realization of a low food loss ethical consumer society opened up by Food DX, we would like to tackle the extremely serious and global social issue of food loss. This center will be located in Japan, but we are considering Indonesia as a test field to prove the concept. First, let me explain why Indonesia. Indonesia is the second largest food loss country in the world. At the same time, Indonesia is the largest fruit producer in Southeast Asia, with an annual production of 19 million tons. The figure in the middle shows the breakdown of food loss in Southeast Asia and the industrialized region of Asia. In Southeast Asia, storage, processing, and distribution losses are very high, and 44% of the food is wasted. On the other hand, in developed countries such as Japan, storage, processing, and distribution losses are limited to 80%. If the storage, processing, and distribution losses in Indonesia could be improved to the level of Japan through technological innovation, it would lead to a 26% reduction in food loss, and the annual reduction in food loss from fruit alone would be about 5 million tons. This amount is equivalent to 0.3% of the world's food loss, and the economic effect would be about 240 billion Japanese yen per year. Next, we backcast the solution strategy based on this 5 million tons of food loss reduction as the future. This project consists of 5 research and development tasks, including a social science task, building a sustainable socio-economic system through ethical consumption, and 3 emerging technology tasks, development of rapid monitoring technology for food functions, development of smart data logger system, and development and utilization of zero-waste recycling food material. Under social science and humanity task, fostering human resources for food solution and creating opportunities through interactive international education program. In this way, 5 research and development tasks will be connected to form a functional cycle of social implementation of the result and further challenges to new targets in an effort to reduce food loss. By 2031, 10 years from now, we hope to establish a resilient food supply chain and reduce food loss from the current 33% to 18%. As a result of emphasizing diversity, more than 1/3 of the members are humanity researchers and more than 1/3 are female researchers. In addition, since this is a long-term project spanning 10 years, the majority of the members are young researchers in their 30s and 40s. I would now like to explain about each R&D tasks. Research and development task 1 is to develop a rapid monitoring technology for food with the concept of cuddle food. In this task, Fukusaki, a leading expert in food metabolism analysis, has already succeeded in rapidly and quantitatively measuring the value of food function and freshness. By further developing this, we will develop food gas metabolism technology and build a model for predicting food function deterioration. Furthermore, we will develop real-time monitoring technology through collaborative research. This research project is connected to the next R&D task. In addition to Fukusaki, who is the leader of this task, Dr. Sastia from Indonesia and Dr. Ida from Shimazu Corporation will participate in this task. In R&D task 2, we will develop a smart data logger system based on the concept of lab food. Under the leadership of Professor Hirose, who is a leading expert in integrated electronics technology, this project will integrate the result of R&D task 1 into a chip using food DX technology, and will integrate automatic food data collection system technology and food gas sensing technology. In addition, in order to prevent food fake, we will attach an ultra-small tag to the food, which records all the data of the food in the distribution process in a form that cannot be tampered with to ensure its authenticity. This tiny piece of equipment is the world's smallest computer. By attaching this computer to individual foods, we are developing food security and safety technology that makes the history of food completely visible. R&D Task 3 deals with the development and utilization of zero-waste recyclable food material based on the concept of bring-up food. In this task, we will develop a reversible freezing drying technology that preserves and restores the original characteristics of food, led by Professor Uchiyama, a leading expert in stabilization technology for biologic pharmaceutical proteins such as antibody and vaccine. This technology minimizes the distribution of food at low temperature and realizes a de-cold chain. In addition, Professor Muranaka and his colleagues, who are leading experts in genome editing technology for practical plants, will play a central role in this project to make effective use of plant and microbial resources that have not been used so far. In addition to the leaders, Professor Muranaka and Professor Uchiyama, Professor Fujiyama and Professor Sakai will participate in the Zero Meat task. Research and Developmental Task 4 addresses the construction of a sustainable socio-economic system through an ethical consumption society based on the concept of watch over food. This task is led by Professor Otsuki, a leading expert in Asian developmental economics, Dr. Michida of JETRO Institute of Developing Economies, and Dr. Honda of Kumamoto Prefectural University, who will quantify the effect of the introduction of the cutting-edge technologies developed in Task 1, 2, 3 on society as a whole in a multidimensional manner using an approach that integrates the humanity and sciences. In addition, we will quantitatively understand the behavior changes of producers and consumers due to the introduction of anti-fake technologies in the food supply chain. Furthermore, we will examine the prospects for ethical consumption and provide guidelines for building a sustainable socio-economic system. Since this task is an important issue that can be regarded as a compass for all targets, Fukusaki, who is the project leader, and Honda and Muranaka, the leader of Task 3 and Task 5, will also participate in this task. Research and Development Task 5 is to develop human resources for food solutions and create opportunities through an interactive international program based on the concept of learn foods. Led by Professor Honda, who has a great experience in international exchange in Asia driven by biotechnology research. This task will establish an interactive international education program for students and adults from Japan and Asia to study together. With diverse members such as Kimura, from the School of Human Sciences, Sugawara and Shiraishi from the School of Foreign Studies, Sumimura from the Global Innovation Organization, Sastia from Indonesia, and Ida from the company. In addition, we will develop human resources who can look at various factors related to food, such as economics, history, religion, and politics, and look to the future. We will produce human resources who can provide new food solutions that promote social transformation towards low food loss and ethical consumption. In order to achieve the vision of this center, we will cuddle food, love food, bring up food, watch over food, and learn food. Osaka University will make a pioneering effort to realize this global vision and create a society in which all stakeholders, for example, agriculture producer, storage distributor, retailer, and consumers, feel happy, are environmentally friendly, and are connected through the food cycle across national borders. Please give us the opportunity to achieve our vision. Thank you very much for your kind attention.